All right, here we go. So we have to rewrite these expressions so they're just a variable to a power, no denominator, no radical. The way it works is when you have a variable in the denominator, you can write that as a negative exponent. So instead of 1 over x to the third, we've got x to the negative 3. The same thing for the cube root. We can rewrite that as an exponent, and it's a rational, a fraction exponent. So this little index is the denominator of your exponent. Questions before we go on? Okay, here's the schedule for today and tomorrow in case you need those times. All right, here's our reminders. We do have one homework that's going to be due on Wednesday before the holiday. Then you got nothing over the weekend. No new quiz this week. If you haven't done the quiz that was due last night, please do that. Get it off your to-do list. That way you can concentrate on your pies this weekend. I'm wearing a shirt to match that. Pumpkin pie is my favorite. And there's no official check-in times in Zoom this week, but if you want to meet with me to go over anything live, just email me. We can make an appointment to do that. All right. Oh, no homework questions. We had no homework. Do we have homework? No, it was quiz review. We didn't have homework. Okay. Basic rules of differentiation. We have finally made it to our shortcuts. Yay. From here on out, we don't have to use the limit unless the problem says use the limit to prove, just like your last quiz did. Now we'll know how to do these shortcuts without the limit. So the first two rules are if you have a linear function and a constant function. If you have a linear function, then the derivative is the slope. Everywhere, the derivative function will be your slope value. If you have a constant function, just a number, then the derivative is 0 because there is no slope. And then we'll try these 8 problems. I'll give you a minute to write those down. Okay, so if a is f of x equals 3x minus 7, then the derivative f prime of x must be 3. The slope everywhere is 3. For b, the function is negative 4x plus 2. It's another line. So the derivative everywhere is negative 4. The derivative of 7x, 7. The derivative, okay, this is 1x. When there's no coefficient there, it's a 1. So the derivative is 1. Any questions on this first column? Okay, so then for e, we've got f of x equals 13. 13 is just a number. It's a constant value. So the derivative everywhere is 0. Pi squared, 3.14159 squared, still just a constant. It's a single number, so that derivative everywhere is 0. Cube root of 10, still a constant. Derivative is 0. Aha, but now for h, f of x is 5 minus x. There's a -1 slope, so the derivative is -1. Any questions before we keep going to when we actually get a type of function that's not linear? Okay. Now for the extra exciting part, the power rule. This is what we were doing with the limits always when it was x squared or some kind of quadratic. If your function is x to a power, where the power is an integer, meaning a positive or negative whole number, then the derivative is this power comes down to be the coefficient, and you subtract 1 from the exponent. What this last part is saying is that your x can't be 0 if you have a fraction. If this exponent is negative, you can't have a 0 in the denominator. So this is just the technicality saying we can't divide by 0, so the base can't be 0 if it's in the denominator. So that's how when we would get a long polynomial and I could quickly find the derivative without doing any limit work is because I was taking the power, making it the coefficient, and subtracting 1 from the exponent. We're going to practice that a few times. There we go, now they all fit. All right, so we've got f of x is x squared. So the derivative f prime of x, this 2 comes down to be the coefficient. Subtract 1 from the exponent, 2 minus 1 is a power of 1. You don't have to write the 1. X cubed, the derivative of x cubed, the 3 becomes the coefficient. Subtract 1 from the power, 3 minus 1 gives me an exponent of 2. Okay, you try C and D and send me your answers in the chat, and you can use the little caret for your exponent to shift 6 for the exponent. Getting great answers. You all are getting the hang of this power rule pretty quick. All right, for C, you're sending me 4x to the third. The 4 becomes the coefficient. Subtract 1 from 4, get a power of 3. And then D, we get 100x to the 99th. Any questions before we get to the second column where we have all these fractions? Okay, so when we have the variable in the denominator, we can't do the power rule. We need the base of x to a power. So I have to change all these like the warm up where to have a negative exponent. So 1 over x, I can rewrite as x to the negative 1. Then do the power rule for my derivative. Negative 1 becomes the coefficient. Subtract 1 from the exponent. So negative 1 minus 1 is negative 2. But we don't leave negative powers in our answer. So I'm going to rewrite this as negative 1 divided by x squared. Just this term with the negative exponent moves back to the denominator. We're going to repeat that for f, g, and h. 1 over x squared, I can rewrite as x to the negative 2. Now I can do the derivative. Negative 2 becomes the coefficient. Subtract 1 from the exponent. But then I have to rewrite that without the negative exponent. So just the x will move back to the denominator. If you have a question or you need me to re-explain something, send it to me in the chat. I'm happy to explain again or say it in a different way if you need it. So then 1 over x cubed is x to the negative 3. Now I can do the power rule. Move the negative exponent back to the denominator. Okay, so I have a chat question about re-explaining the first column. So the power rule says this exponent becomes the coefficient here, then subtract 1 from your power. So like for C, the 4 comes down to be the coefficient, and then 4 minus 1 is the new power of 3. So 100 comes down to be the coefficient, subtract 1, new power of 99.
I'm super tired.
Okay.
I'm super tired. Now in 30 minutes.
Move the negative x back to the denominator. Now notice none of these problems had a coefficient to start. That's our next page. But it's going to be a very similar process. So do you have any questions here before we get to the last rule for today? Okay, so now the constant power rule. It works the same way as what we were just doing, except if you have a coefficient now, the derivative, you have to then multiply your coefficient and power for the new coefficient. So it still works the same way where the power comes down to be the coefficient, subtract 1 for your exponent, but now we just then combine those numbers, we multiply to get the final value of the coefficient. So we're going to do that 4 times. So if our function is 3x squared, the 3 coefficient carries over, the 2 comes down, subtract 1 from your exponent, multiply the 3 and the 2, so your final answer is 6x. You don't have to show this in between step with the 3 times 2. If you can do that in your head, that's absolutely fine. I'm just trying to show you the progression of the steps, like how we wrote it out up here with the rule. The coefficient carries over. The exponent comes down. Subtract 1 from the new exponent. And you get 6x squared for the second derivative. So for C, we got 5x to the 4th. So when the 4 comes down, so this is what I'm saying you can do in your head. 5 times 4, that's 20. X, subtract 1 from the power, and our derivative is 20x cubed. All right, one more. The function is negative 2x to the 100th. So the derivative function, the slope everywhere will be the equation negative 200 x to the 99th. What questions do you have before we use the power rule to do some problems? Okay, so then we've been doing all along the tangent line, so you don't have to write this down unless you really want to. This is the same concept that the slope of the tangent line is the derivative. This is our point slope form where we have x1 and y1, and the derivative is our slope. That's we've been doing that since the beginning of our derivative units. Point slope form is our favorite. If you want to write it down, I'll pause here. If you already got that or you have that on your summary sheet, you don't have to copy it again. Okay, so here's how we're going to use the power rule and the equations of the tangent line. This is the kind of problem that we're going to practice with. Go ahead and write down all 4 parts and the given function, and then we'll do every part together. What was the equation? So point slope form, that is y minus y1 equals m x minus x1. Where m is our derivative at a point. This is the x value, and then this is the y value at that point. So the power rule saves us a ton of work where we don't have to do the limit as h approaches 0 to find the derivative. I don't have to use the calculator to get the derivative. I can just look at 3x squared minus 12x plus 8 and take the derivative of each part of my polynomial. So the derivative function will be this 3x squared using the power rule. 2 comes down. We get 6x to the first minus, because it's a subtraction. And then 12x to the first, you can either think of 12x as the linear part of the equation and just take the slope, or you can do the power rule. 1 times 12 is 12. 1 minus 1 is 0, so that x goes away. There is no variable left there. And then 8 is a constant, and the derivative of a constant is 0. So our derivative is 6x minus 12. What questions do you have on applying that power rule? What happened to the plus 8? So plus 8 is a constant. And that very first rule is when you have a constant, the derivative, the slope of a constant is 0 because it's that horizontal line. There is no slope. So when I look at for the domain of the derivative, 6x minus 12 is a line. The domain of a line is all real numbers. So x is all reals. For the equation of the tangent line, I'm given my x1 and my y1. Yes. 2 out of 3 parts I'm already done. The only thing we're missing is the slope. But slope is derivative at a point. So if I take my 3 and plug it into my derivative, I get the slope of the tangent line. And I'm using 3 because that's the value they're giving me here. So I can also think of this as a and f of a. So that's our slope. The derivative is 6 at 3. The slope is 3. So our tangent line is y minus y1 equals m x minus x1. Minus a negative, I'm going to make that look nicer. We get y plus 1 equals 6 times x minus 3. So this is point slope form. If we wanted slope intercept, that's y equals mx plus b. I will always start with point slope form because all I have to do is isolate y to get slope intercept. I can distribute the 6. And then subtract the 1 over. To convert forms, but I will always, 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 always start with point slope form because regardless of what either the multiple choice is or the answer key, I can get slope intercept from point slope. So point slope is our best friend in calculus. We are going to use point slope all the time. Okay, last part. What are the points where the tangent line is horizontal? Horizontal means a slope of 0. So part D is asking us to find anywhere the derivative equals 0. I'm going to need this equation in a second. Okay, so take my derivative, 6x minus 12. When does that equal 0? Solve for x. There we go. But I'm not quite done because the question says point, not just s value, but the point. So the point is 2 comma something. I need this y value. And we get the y value from the original function, not the derivative. Derivative is slope. Y value is original function. So I'm going to substitute 2 into my original function to get the y value. You can use a calculator to calculate this. So the point where the tangent line will be horizontal is at 2, negative 4. This is our final answer. This is the point. This is the process you're going to practice on the homework that's due Wednesday.